Degree of hardness of water is given by the formula weight of CaCO3, calcium carbonate. Weight of CaCO3 in grams divided by weight of water. Weight of water means weight of hard water we can take. Weight of water also should be taken in grams into 10 power 6. 10 power 6 indicates what? 1 million. So this degree of hardness of water is measured in which units? ppm. ppm stands for what? Parts per million. So parts per million. Okay. 1 million is equal to how much? 10 power 6. So the degree of hardness of water can be calculated by using the formula weight of calcium carbonate in grams upon weight of water into what? 10 power 6. Okay, that means in 10 power 6 parts of water. In 10 power 6 means 1 million. In 1 million parts of water, how many grams of calcium carbonate is present? Is known as what? Degree of hardness. Suppose example I am taking one. Example 1. Suppose we have 10 grams. 10 grams of CaCO3 is present in 10 kilograms hard water. In 10 kilograms of hard water, how many grams of calcium carbonate is there? 10 grams. Then they are asking calculate hardness. Calculate hardness of water. Now, which formula we have to use? This formula. Degree of hardness of water, we have to use formula. Now, tell me directly given how many grams of calcium carbonate here? This weight is given what? 10 grams. And the weight of water, how much given, mind this? The weight of water, how much? 10 grams or 10 kilograms, how much is given? 10 kilograms given. What is given? 10 kilograms. So now 10 kilograms we have got here. Now 10 kilograms means how many grams? Tell me. In 10 kilograms, how many grams will be there? 10 into 1000. Na? Kilo means 1000. So these many grams is present here. Means 10 power 4. 10 power 4 grams of water is given. So the weight of water, how much now? 10 power 4. Right. So 10 divided by 10 power 4 grams of water into 10 power 6. Then what will be this now here? How much we are getting? ppm. What is hardness of water now? How much we are getting?
10 power 3.
10 power 3. 10 power 3 means what now? 1000. So 1000 ppm we got. 10 power 3 means 1000 ppm is what now? Hardness of water. Is the concept clear now? Sometimes
Yes, sir.
calcium carbonate will not be given. Remember, calcium carbonate will not be given. Some other salt of calcium or other salt of magnesium will be given. In that case, we have to convert the other salt into the equivalent weight of this calcium carbonate. That example we will discuss now. Sometimes calcium carbonate will not be given. Some other salt will be given, calcium salt or magnesium salt. In that case, we have to convert that weight of salt into equivalent weight of calcium carbonate. Sometimes calcium carbonate is directly given. So this is one concept. Okay. If you want, you take screenshot. We'll go to next page. Now, example 2, check it out. Example 2, based on this hardness of water. Suppose they are giving what? 11.1 grams CaCl2. CaCl2 is present in same you take 10 kilograms. 10 kilograms water. Okay. Then calculate degree of hardness. Degree of hardness they ask you to calculate. Suppose. Now in this case, what we have to do now? Same formula we have to do. What is the formula? Tell me. Weight of calcium carbonate in grams upon weight of water in grams into 10 power 6. The same formula we have used. But here calcium carbonate is not given directly. What is given? Calcium chloride is given. What is the gram molecular weight of calcium chloride here? Gram molecular weight. Calcium how much? 40. And Cl atomic weight 35.5. 35.5 into 2. How much? 71. 71 plus 40. It will be 111 grams per mole. In 1 mole of calcium chloride, how many grams present here? 111 grams present. So 111 grams of CaCl2. It is what gram molecular weight. Okay. Now this 11.1 grams of calcium chloride should be converted into what? Equivalent weight of CaCO. CaCO. How to do we check? Now 111 grams, that's gram molecular weight of CaCl2 is equivalent to 100 grams of CaCO. 100 grams CaCO. Here 100 grams is what now? Gram molecular weight of CaCO. So it is what now? Gram molecular weight of CaCl2. And what is this 100 grams here? Gram molecular weight of calcium carbonate. So 111 grams of CaCl2 is equal to 100 grams of CaCO. But here in the question, how much is given? 11.1 is given. Then 11.1 grams of CaCl2 is equivalent to how much? Now do cross multiplication here. So 11.1 into 100 upon 111. Now this value how much here? 11.1 by 111 how much? 1 by 10 na? 1 by 10 into 100 how much? 10. So it is 10 grams CaCO3 we have to take. So 11.1 grams of CaCl2 is equal to how many grams of CaCO3? 10 grams. Now tell me what is the degree of hardness? Degree of hardness. What is the formula now? Weight of CaCO3. Weight of CaCO3 how much? 10. 10 grams upon weight of water. Weight of water how many kilograms given? 10 kilograms. 10 kilograms means how many grams? 10 into 1000. So 10 power 4 grams into 10 power 6. It is 1 million. So this is the formula here. Calcium carbonate weight, weight of water into 10 power 6. Now how much we are getting? Tell me. Again, 10 power
10 to the power 3.
power 3 ppm. Parts per million. So here 10 power 3 ppm, what does it mean here? 1000 parts of CaCO3 is in 10 power 6 parts, means 1 million parts. 1 million parts of what? In 1 million parts of water, how many parts of CaCO3 is present here? 1000 parts present. This is called ppm. Is the concept clear, ma'am? So this is what now here?
Yes, sir.
Yeah, the concept of ppm. And now, suppose you are given any other salt. Suppose you are given what now? Calcium sulfate is mentioned. Calcium sulfate, what is the gram molecular weight? GMW. Gram molecular weight, how much? Calcium, how much? 40. Plus sulfur, how much? Atomic weight? 32. Plus here oxygen 16 na? 16 4 64. So it's gram molecular weight. How much it is now here? Tell me. 136. So 136 what now here? Grams per mole. This gram molecular weight. That means here 136 grams of CaSO4 is equal to how much now? Is equivalent to 100 grams of CaCO. Is the concept clear?
Yes, sir.
So
Yes, sir.
100 grams of CaCO3 is equal to 136 grams of CaSO4. And also that is equal to 111 grams of CaCl2. Like this, any salt we can take that. And also we can take dash grams of MgSO4. We can get it now. MgSO4 gram molecular weight. How to get? Mg is what now here? 24 atomic weight. And sulfur atomic weight 32. Less 16 for the 64. It will be gram molecular weight. So like this, gram molecular weight of any salt given, we can equate with 100 grams of calcium carbonate. So any salt may be mentioned in the question. We have to take it confident. So is the concept of degree of hardness is clear now? So it's about degree of hardness. Now next, one more important concept of this is volume strength. Volume strength of H2O2. What do you mean by H2O2 here?
Hydrogen peroxide.
Peroxide. Hydrogen peroxide. So this concept also is important based on this question. Remaining theory part you can understand, no problem. So now in this case, now volume strength of H2O2, mainly what you have to remember is that 1 molar H2O2 is equal to 2 normal H2O2 is equal to 11.2 volumes of H2O2, that equals to 3.4 weight by volume percentage. 3.4 weight by volume percentage. So this relation mainly you have to remember. The relation we have to remember mainly. Okay. So this one, if you remember, easily you can do any type of problem based on this. Okay, ma'am? Now tell me what is the molarity of H2O2 taken in this now? Molarity of H2O2, how much is taken? How much molarity of H2O2? 1. And what is normality of H2O2 given here in this relation? 2. Normality 2. And what is the volume strength of H2O2 given in this relation now? H2O2 volume strength
11.2.
11.2 volume strength. And what is the weight by volume percentage given here? Weight by volume percentage? It is 3.4. So if you relate this one, it will be easy to calculate. And now check it. Suppose we are given one question like calculate. Example 1 will take first. Example 1. So now volume strength of 10. Okay. Otherwise, 2 normal. Volume strength of 2 normal. Otherwise, 2 molar you take better. 2 molar H2O. Now, what is molarity of H2O2 given in this? Volume strength of 2 molar H2O2 is dash. They ask the question like this. Now, what is the molarity given here? Molarity of H2O2 given 2. So, molarity is equal to 2 moles per liter. 2 moles per liter given here. So, here 1 molar is equal to how much volume strength? 11.2. So, we have to take like this first. So, we have to take that 1 molar H2O2 is equal to how much volume strength? 11.2. 11.2 volume of H2O. It is from relation we have to recall first. Then the question, what is given? How much molarity given? 2 molar. Then 2 molar. Then 2 molar H2O2 is equal to how much? Now do cross multiplication here. So 2 into 11.2 upon 1. That equals to how much, ma? 11.2 into 2, how much? How much? 22.4. So 22.4 volume. So 2 molar H2O2 is equivalent to how much volume strength here? 22.4 volume. So what do you mean by 22.4 volumes meaning here? Now you have to understand. If volume strength is equal to 22.4, what does it mean here? That means 22.4 ml O2 gas can be obtained at STP. Okay, by decomposition of what? By the decomposition of 1 ml H2O2. Is the concept clear, ma? 1 ml of H2O2, if you decompose, if you dissociate 1 ml of H2O2, how many ml of oxygen is coming here? 22.4 liters of oxygen gas is coming. At what? At STP condition, standard temperature and pressure condition. Is the concept clear? So 22.4 volume strength means 22.4 ml oxygen gas will be released at STP by decomposing how many ml of H2O2? 1 ml of H2O2. Suppose if volume strength equals to 10, suppose. If volume strength equals to 10 volumes. What do you mean by this? If volume strength is 10 volumes, what do you mean by this? 10 ml O2 gas. 10 ml O2 gas at STP. Okay, is obtained from what? Is obtained from 1 ml H2O2. From 1 ml H2O2, how much is coming now? 10 ml of O2. This is called what now? Volume strength concept. So how H2O2 will decompose actually? H2O2 will decompose into 2H2O plus O2. This O2 gas will be coming. So 2 into H2O2 will give 1 mole of O2. Now here how many grams here? 2 moles there here. 2 moles means H2O2 gram molecular weight how much? Gram molecular weight of H2O2, here 32 plus 2, 34. 34 grams per. Now, here how many moles available? 2 moles of H2O2 is available. So 2 into 34. 2 into 34, that is what now? 68 grams. So 68 grams of H2O2, if decomposes, we are getting how many moles of oxygen gas? 1 mole. 1 mole of oxygen means how many liters? 22.4 liters. Okay, so 22.4 liters of oxygen is coming by decomposition of how much? 68 grams of H2O. This concept is taken from what? Balance equation of decomposition of H2O. Is the concept clear, ma?
Yes, sir.
Tell me anyone now, what is the meaning of volume strength 5? If volume strength of H2O2 is 5, what does it mean? 5 ml oxygen comes
5
from
ml oxygen come from STP
1 ml, 1 ml H2O2. That's all. There is a relation to the answer. Now, next, suppose you take 100 volumes. Suppose. Now we are taking. Now one more question here. Example 2 I am taking. Calculate molarity, normality, weight by volume percentage of 100 volumes, H2O2, 100 volumes H2O. This is question here. Now what they asked to calculate in the question? Molarity, normality, and weight by volume percentage. Weight upon volume percentage. These three they asked. Okay. Now first what we have to recall, tell me. What we have to recall, one equation, one relation I told now. 1 molar is equal to 2 normal is equal to 11.2 volumes is equal to how much I told you? W by weight percentage, the weight by volume percentage, 3.4. Weight by volume percentage. Now here, in the question, what is given? Tell me. What is given here? 100 volumes means what is given? This volume is given. Volume strength is given. They asked to calculate molarity. They asked to calculate normality. And also they asked what? W by 3 percentage. Now first case. In first case, what we have to understand? 11.2 volume is equal to how much molarity, ma? Equals to how much molarity? 1 molar. 1 molar H2O. It is from balance. This equation we have recorded. So 1 molar is equal to 11.2. So 11.2 volumes equals to 1 molar. Then how many volumes given in the question? 100 volumes. Then 100 volumes will be equal to how much? Again, cross multiplication we have. Tell me how to 100 into 1 molar upon 11.2. So it will be approximately equal to 8.9 molar. 8.9 molar. That means 8.9 mole per liter. Okay. In 1 liter, how many moles of H2O2 will be present? 8.9 moles of H2O2 will be present in 1 liter of solution. 1 liter of water. Is the concept understood now? How to calculate molarity from given volume strength? Now, second, after calculation of molarity, then what they asked to calculate? Second one, normality. How to calculate normality? Tell me. 11.2 volumes is equal to 2 normal. Then 100 volumes equal to how much? Like that we have to. Next, another concept is that what is N factor? N factor of H2O2. N factor of H2O2 how much more? 2. N factor meaning what here? Basicity. Basicity of H2O2. That is N factor of H2O2 is equal to how much? 2. So generally relation what now? Normality is equal to molarity into 2. N factor. Molarity into N factor. So molarity into N factor is equal to what? Normality. Here N factor of H2O2 how much? 2. Then molarity how much we got already? 8.9. So 8.9 molarity into N factor how much here? 2. Now 8.9 into 2 is equal to 17. 17.8. So 17.8 normal solution. If we calculate molarity, we can get normality directly. Normality is equal to molarity into n factor. And n factor is 2 here. Why n factor 2 here? One molecule of H2O2 can produce how many H plus ion? 2 H plus ion. One molecule can produce 2 H plus ion. That's why it is what now? Di-basic acid. H2O2 is an example of what? Di-basic. Means basicity is 2 now here. That's a di-basic weak acid. Di-basic weak acid. So di-basic weak acid we have taken H2. So if you know molarity, we can get normality directly out. So 100 volumes of H2O2 is equal to how much normality here? 17.8. Is this okay? Is this concept clear up to this now? So normality, molarity we can
Yes,
tell.
sir.
So next, what is asked here? Tell me. Also, what they ask W by V percentage, weight by volume percentage of 100 volumes they ask here. Now next, how to get? Tell me now. From this relation, we can say that 11.2 volumes is equal to what? 3.4. 11.2 volumes equals to 3.4. Then 100 volumes equals to how much? 100 volumes equals to how much? So next case, what we can get? 11.2 volumes is equal to 3.4 weight by volume percentage. Then 100 volumes. Then 100 volumes equals to how much? Now how to get now this one? Tell me. 100 into 3.4 upon 11.2. That is approximately equal to 30% you can take. 30 W by V percentage. Weight by volume percentage was 30%. What do you mean by 30% weight by volume? 30 grams H2O2. 30 grams H2O2 is present in 100 ml solution. In 100 ml solution, 30 grams of H2O2 is present. That is the concept of this 30 W by V percentage. Okay. So from this again, now molarity also we can get now. Molarity also we can get. Molarity is equal to formula what generally? Molarity M is equal to weight upon gram molecular weight into 1000 by volume of solution in milliliters. Now we can substitute now here. M equals to weight of H2O2. How much is there now? 30 grams upon gram molecular weight of H2O2. How much? 34 grams per mole into 1000 by volume of solution. How much here? 100 ml. 100 ml. So again here it will be nearly equal to what now? 8.9 molar. Again molarity we get 8.9 only. Okay, it is about what now here? Weight by volume percentage, molarity and normality calculation from volume strength of H2O. And also remember this 100 volumes of H2O2 is called perhydrol. What is the name of that? PER, per hydrol. Remember that? 100 volumes of H2O2 is known as what? PER hydrol, perhydrol. So the question may be directly asked here. For perhydrol, what will be weight percentage, weight by volume percentage? 30. 30% weight by volume. And what will be molarity? 8.9 molar. And what will be normality? 8.9 to 2, 17.8. 17.8 normality. So normality we can say directly. Molarity we can remember. W by V percentage also we can say. For what? Per hydrol. Per hydrol means what? 100 volumes of H2O. So did you really understand concept here?
Yes, sir.
These two are very important concepts of this lesson. Hydrogen and its compounds. Numericals means these only will come from this. Remaining theory part you can study. You can understand properties and all. Chemical properties and preparation methods. Okay. So it's about what now? Hydrogen peroxide. And tomorrow we'll discuss in class also, regular period also, when JEE Mains examination is going on. We'll discuss about this in physical class. Is that okay?
Okay, sir.
Yes.
Yeah. Bye now. Good day. Good night.
Thank you, sir.
Bye, sir.
Good night.
Sir.